Right, it's fairly early in the morning. I've not long been up, and I'm drinking a coffee in my Danger Mouse mug. Right. This is my bench frequency counter, the one I did have, which I've recently replaced with the Record Dana, which I repaired that in 1992. And I was going to sell this. And I was taking pictures of it, I'd done pictures of the outside and stuff, and I powered it up to take a picture of the display. And nothing happens. Now, this was on my bench, been working perfectly for years, and now when I want to go and sell it, it's decided to play up. Now, what I did on the back here is I actually hooked up to the output on the back, the 10 MHz output, and I wasn't seeing any frequency there. So I'm wondering if maybe the oscillators decided to die suddenly. So I'm going to pull this thing apart and see what we can find out. I might be too close with this camera. I might have to back it out a bit, but we'll see how we go. Yeah, so I don't know what's happened here. Maybe something's come loose, and when I've moved it, it's just lodged something. I don't know, but so it was working absolutely fine. I've never had any issues with this. And so when I go to sell it is when it plays up. It's really odd. So we'll find out what happens. If I remember how to get the thing apart, that's another issue too. How do I get the thing apart? Okay. Okay. I don't remember get this thing apart. Let's give me a second. I think the top lift's off. That's right. The top lift's off. There we go. It's been a while since I even opened that and had a look inside it to calibrate it and stuff. Okay. There we go. So there's the inside. Now we do have power because the little light which I put in the side of the display is lighting up, but we don't have 10 MHz for some reason. That's not there. Now that makes it somewhat interesting. I'm not quite sure where to start right now. Bear in mind that it says currently plugged into power, so I need to make sure I don't just poke my fingers everywhere. That'd be bad. So that's the power supply section here. So what I can probably do is check for voltages and see if it's there. Although the fact that I've got the light on the front means there is power between here and here, right? So these are the wires that go into the bulb I've got on display. And I think that's 12 volts there. There's a 5 volt regulator over here. Let's just have a look. Let's clear my chair off, got some stuff pole on it. Another job I was going to do yesterday, but I couldn't do it. I was a bit busy something else. Right. So I think 2p10 is the negative. Nothing now. Power up. No 5 volt rail. Oh, try that. So it's on the same point, doesn't it? Okay. It looks like there's no 5 volt rail. That's a 5 volt supply. There's nothing there. That's 10 volts there. Is something loading that down? What's happened? That's the question. What has happened? There's big capacitors here, but they'll be the main power supply input. There's a smaller cap under there, a couple of them. I might have to pull this thing right out the casing and work on it that way, but it's a little bit dodgy. So it is mains powered. So, but it does actually have a it does have a low power input on it as well. I might switch to low voltage, use DC input. That might be an option. Well, let's unplug this G5E board first and see if that will change anything, just in case there's a GPIB issue. No, that didn't change anything, so okay. Alright, well, there's a Sprague cap under there, looks like a Sprague cap. Yes, what's going on here? What is going on? Where's the 5V gone? I don't know what that does, but there's no power in any of it. That may be a clue. Very interesting. Alright, well, this is going to require some further investigation. I'm going to have to come back. Okay, so this is the circuit diagram for the HP5384A, as you can see up here. Now, this is the section of the power supply, which is obviously where I'm interested, because I've got the light coming on, which I put in, but the 5V supply is dead. Now, this makes it look extremely simple, and it probably is very simple, actually. Now, what we've got here, you've got the main AC line coming in, which is fused. You've got a selection here for the 230 115V option. Obviously I've got it set for 230 for my country. Through here, DC bridge rectifier. I don't know what the voltage is at this point, but it won't be very high. I think it's probably only about 12 volts. I have to actually measure that. Then there's another fuse here. Now, I didn't see two fuses. I saw this fuse. I didn't see this fuse. So it must be in there somewhere. So my light is actually, this is the main power switch here, and I've got it linked off that power switch. Right, so my light is connected to here. Alright. So the one I've got on the acting as backlighting for display. That's on that point there. So, right there. Deselect. Now, I know I've got power at this point then. What I don't have is power at this point over here. Alright? TP8. So, I think that's what it said, TP8, wasn't it? It was 5V rail. Oh, this is TP2 on there. Interesting. Well, that's TP2 there, not TP8. I don't know where TP2 is then. I should find that too. But I shall have to find this TP8 point and check for voltage here. But I've got no 5V rail, which means this is probably not powered. U7, is that the one I checked? No. This is Marcus Q10. Dear. This is Q10 just here. Just there. Alright, and I had no voltage on any of the pins, which means there's no power here. Okay, so that's fine. Alright, so no power there, which means it is probably this fuse here which is gone. Why is that gone? Could be this capacitor, could be that capacitor, could be this capacitor. Alright, could be this capacitor over here, although that's unlikely. I'm not quite sure what the deal is here. I'll have to look into that maybe, but just out of interest. So it's looking like it could just be the secondary fuse that's here is blown, and maybe one of these capacitors here are a bit dodgy, which is why it's gone when I've powered it down and not anything connected to power. So it's normally plugged in all the time, and when I've not done that, it's obviously gone. So it could be a dodgy capacitor on these two. 220, well, 2200 UF. I've got some of those. They're only low voltage, so there shouldn't be an issue. Yeah, right. So that's that bit. Okay, so after having a look at the diagram, F2, obviously, is actually on the rear of the unit, right there. So let's get this out, and oh, look, it is blown. It is blown. So why is that blown? Old, maybe? Could be old. Let's put a new fuse in and see what happens, and see if another one blows. Let's have a look. Be right back. Fuses, 2 amp. Right. I'm replacing 2 amp fuse, which looks intact. Verify is 2 amps. F2A, 250 volt. Yep, fine. Let's drop this in. And then we shall try this one. But yes, the fact it actually blew in the first place is very interesting. I mean, it's not something that should happen. So there may be an issue. Maybe the oven's a bit dodgy. Now it's gone cold. Who knows? Let's go a power cable. You have power again. Wow, that was easy, wasn't it? So it just goes to show, don't overlook the obvious. So let's plug this board back in again, and I left it unplugged in case I had to take it out. But yes, why did that go? That's the question. Is there an issue here? I mean, all the caps look fine. I can't see any issues with the caps. They all look absolutely fine. I have to take the whole board assembly out to be able to test them, unfortunately, which may be a little bit involved. It might be okay. Looks like it might just be 2 screws. Must be 2 screws. I'll probably drop that out and just check those caps just to be sure, but you know, it's working again now. So, you know, that's the important thing. Let's pull the power. Let's have a look. Just let's just do that, shall we? Let's just do that. Just for the sake of completeness and just to be sure, because I mean, I'm selling this. I want it to be in good condition when I sell it. I don't want it to fail after they get it. You know, I don't want that to risk. I want it to be sold, and for the person that buys it to be happy with it. So, you know, a fuse usually goes for a reason. No, great, it's not magnetic. Yeah. Right. Is that over it? Don't know. Maybe. Yeah, it's coming out. Right, let's turn up over the other way. There we go, there's the bottom of the bolt. These little side pieces that go on the casing. I'll put that back in after. Right, let's have a look around. All looks okay. Nothing obvious. Let's get my meter here, do some tests, and see what we can find. The first thing I'm going to do with my, obviously the coolest meter around, check the capacitor voltages. Because I don't want to be touching these things with my hands if they've still got power on them. That'd be bad. Should be the same anyway. Yep. Yep. Those discharged, that's fine. So let's measure things. I haven't really got the right hose for this right now, but this will do. That'll do just fine. Capacitance on series capacitance with ESR. Right. .06, 670, might be right. Come on, it's bad connection probably. Ooh. Now that's interesting. This one isn't giving a reading. Has this capacitor failed? Nothing there. Nothing there. There is another capacitor underneath that board, which is just over here. Let's just make sure it's taking the discharge. We'll stick the meter on it. Let's just check this one too. Yeah, it looks okay. And there's also this one just here. Just to make sure there's no residual power in any of them before I stick my meter on. Yeah, that looks about right. So those look. I haven't checked those values out, but they look about, you know, acceptable. You know, what we kind of expect for those kind of size capacitors. But this one here might be gone. So maybe that's what's caused that fuse to go. Is this capacitor here shorting out and then blowing. So it's not getting anything at all in that one capacitor. And those terminals should be joined together anyway. Oh, and I get the same on that one as well. Yeah, that's interesting. I've got a value of that before. Let's try a different measurement, shall we? Let's put the EV bog one out and see if this can measure it. You never know. Get right around. What did I say these were? 2200 UF. Is that what I thought they were? They're both charging up. So this seems to think they're okay. Well, at least working. This could require some further investigation after all. Okay. Well, let's have a look at these caps. Yeah, 2200 UF, 25 volt. Maybe I should just replace them because I'm suspicious. 2200 UF, 35 volt Nichicon. Right, so I've got caps to put in. Right, not a problem. I've got caps, so I'll just take those out and change them. Obviously, these are 3 terminal caps. I've only got 2 terminal caps, but as long as there's no links on the top of the board, it should be okay anyway. Alright, so I'm going to pause this while I warm up my iron. Well, I've got the first capacitor out. It wasn't easy getting it out because it's got like double ground plane. So you've got to try and get all the heat sink right through that board. Anyway, so the double pins will be the negative and the single pin is the positive in this case. Alright, so when I was actually hooking up the LCR meter, it was actually backwards, but it probably didn't matter anyway. But yeah, there's a lot of heat sink in there involved, and it's pretty hard to get it out. So there's a cap for one of them anyway. Let's hook this up to the meter again, just for curiosity's sake, and see what we get. Guess you can't read this high, so that's fine. Let's see what else I can use. I have other solutions. I have this little meter for a start. battery in it? Yes, there is. Oh, this is an ESR of 0.01. No, yeah. I mean, ESR itself looks okay, but yeah, I don't know. I'm a little suspicious about these caps. I mean, something with that fuse. So I'm just going to replace these. Now, what I've actually decided to do is using those big 35 volt ones, so I'm going to use these 25 volt ones instead. These are basically the same spec as these existing ones, just a lot smaller. Yeah, well, it's got the same ratings. 2200, 25 volt. So I sure. The only thing is the spacings are somewhat different, but I'm sure that's not really that much of a problem. Now I've got to get this other one out, so that's going to be fun. Biggest problem with this is because there's so much ground plane there, so I'm going to actually record doing this one. Because there's so much ground plane there, it's really hard to get the heat through it. So it takes quite a bit of effort to get the heat through and get it desoldered with the other side. So the first thing I have to do is get it all wetted and get the fresh solder starting to take. Okay, so it takes a bit in itself. Then I'll get this desoldering iron going. I'll desolder that pin there, which is one of the easy ones to get off. And then I can start wiggling the things around and easing them out. I can't just desolder it, just doesn't. There's too much heat sink there, so I just have to do it gently and slowly wiggle them out. Just working between these. I'll try and put all that heat into that plane. My iron's set quite low. It's relatively low. It's 340 it's on right now. So no, it's not surprising. It's taken a little while. These older boards, if you put too much heat into them, they'll actually damage the boards, and the traces come off quite easily and things like that. So I'd rather have a lower temperature on it and just take my time. Just want the fresh solder to take, then I know I can get a decent desoldering going on with my gun. Yeah, it's starting to take. Right. This gun's got a lot more power behind it than my actual soldering iron has. So I just need to make sure I've got fresh solder so I can actually suck it all out. There we go, that's that one off. Let's see if I can get more luck with these ones. Last time I couldn't do it, there's just too much heat play. Just couldn't suck it right through the board. I have to wiggle it out. Yeah, let's do it this way for you. Hopefully be able to see. So even just trying to get the iron to melt that is here we go. Alright. Gives you an idea how hard it is. Now that one's not quite gone. Hey, I actually desoldered that one. Cool, that one went. Right, this one should be a bit easier then. Come on. Here we go. Hey, got that one. That was easy in the last one. Right. So here we go. It's out. So let's have a look at this one. This one measure this. Yeah, so this one's twice as high as the other one, although it's drifting down. It is a bit warm still from desoldering it. Yeah, let's jump around, maybe still these connections. Yeah, okay. It's similar to the other one, but I don't know. So I'm still suspicious about them. I'm still suspicious that it's not right. So we'll see. So now I'm going to put these ones in, which, you know, a bit of a size difference, and at least that's all just grounds there, so this is easy. It's just a shame the lead spacing is very different, but ultimately it doesn't really matter that much. As long as you get the polarity right. Now I need to make sure I get this like so the positive lead goes straight through, the negative will be the one that's bent to the board, because it doesn't matter because of the ground plane, because that's the negative rail there, so just do that. Okay, so the positive straight through and the negative is the one that's bent, just like that. Right, solder those in. Obviously I have to tack these down to make them nice. You might need some flux on these. Where's my flux pen? There it is. Just to help it a little bit. This solder has got really good flux in it anyway, so it tends to do quite a good job. So I'm not overly worried by that, but it's just nice to be sure that you've got plenty there. I might even solder these from the top as well if the solder doesn't go right through very well. It should go right through, but make sure plenty of heat into it because of the ground plane taking it away. Right, that looks like it's okay. And solder did come through to the top, so that's fine. Bit of a shame having to do this, you know, because I was going to sell it. Well, I'm still going to sell it, but I don't want it to come back saying, you know, hey, it's stopped working or something, you know. I want it to be out, and then I want it to be good, and I want people to be happy with what they've got. I mean, I've had no problems with this at all. The whole time I've owned it, it's been absolutely fine. But it chose the time I want to sell it to the time that blows a fuse. So, yeah. Anyway, this should at least be, you know, a help. Should at least be a help. Okay. This side here doesn't look too bad. I might stick a bit of solder on that side as well, just to be sure. I'm not completely sure it's good enough. I mean, it is true, but I'm not sure it's done a good enough job on that ground plane. You can see by the fact you've got the crosses by the holes means they've actually tried to mitigate the heat loss when they've designed it. So they've tried to allow for that, but you know, sometimes it's not quite enough. Yeah, slightly better. Just want to make sure good connections, and I think I can get down there and clean it. Oh, pulled the wrong thing off. I'm just getting there to clean it. Okay, right. So I need to secure those down so they don't move around, and I'll power it up. And I think I'll be satisfied enough that that's okay now. It's likely that these capacitors will cause that to blow. I mean, they're old. I mean, what year is this thing? I don't know if it says anywhere what year it is. Look for date stamps. 86, 23rd week 86, 28 weeks 86, 44th week 85. So, you know, it's mid 80s. You know, mid to late 80s. So this thing's, you know, 30 years old. So, yeah, you expect to do stuff like that. So there is another capacitor under there, but they measured okay. So I'm not worried about those other two little caps under there, and they're okay. There's also this one just here, and that one just there. Let's test those, just in case. .1 UF, 3.3 UF, and the ESI looks okay. I can't see what the rating is on this one. 110 UF, 0.31. Well, I can't see it because it's underneath it. Yeah, I can't see what value that is, but ESI looked kind of okay, you know, 0.31. Yeah, it's alright. So I think that's probably fine. So I'm going to secure these down and put it all back together. No point fill. Right, so I've got it back together. I've got the power cord plugged in. Let's see what happens. There we go. You have power again. All good. So yeah, I'm just suspicious that these two capacitors here was what the issue was. You know, although they look fine and they measure kind of okay, it's like, well, something blew that fuse, and the most likely thing is going to be these. So just change them, have done with it. You know, it's cost me a few dollars, so what? It's better to sell something which I'm more confident about being okay. This is the original fuse, and so yes, it was a, hopefully you can see it on there. So it is rated 2 amps. It is a 2 amp fuse. Alright, so it wasn't like it's the wrong rating or anything like that, because you know, you might come across that sometimes. Someone's put in a fuse which all they had was, say, a 1 amp or something instead of the right value. You know, it can happen, but it's the right one. So it blew. And anyway, at least it's a fairly simple fix. So that's it. All good. Now I can sell this thing. But actually, I'll bench test it a bit longer first. I'll leave it on, power on for a while, and just do some thorough testing before I sell it. But you know, I'll have it on for a while just to be absolutely sure in case something else is going on. But otherwise, we're good. So catch you later. Have a good one. Remember to subscribe, all that usual stuff. And tell your friends. Bye bye.